This is pre-calc lesson 80, number 26. And so here's our problem. On a problem like this, when you have radicals, you're going to want to isolate the radical so you can square both sides and get rid of the radical. So I did that. Squared both sides. And then I added cosine squared theta to both sides. That gave me 4 cosine squared theta equals 2. And then I took the root of both sides. I could have actually brought the half over here and factored a difference of squares, which is how the book would have us do it. I still got the same answer. I got 1 over root 2, plus or minus 1 over root 2. So if it can be plus or minus, that means it can be in any quadrant. So adjacent, or cosine is adjacent over hypotenuse. So it's 1 over root 2. So that's a 45, 45, 90. So, but we're supposed to be in radians. So this would be pi over 4. I think this is 3 pi over 4. Because can't you go like this? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So there's all my values. I'm supposed to check them though, because I squared a radical. So you're supposed to check and see if they make it true or not, like if I plug them in. I will just tell you that if you plug in, so how would I plug it in? You could just plug it in right there and right there and see if they zero out. If you plug in the negative 1 over root 2, I don't want to do it right here because I have lunch duty in a minute here, but if you do plug in the negative 1 over root 2, if you plug it in here and here, it's not gonna equal 0. So you have to throw away the negative ones. Okay, so this is so you want to keep this one because cosine's positive here, and you want to keep this one. And these ones you're going to throw away, and you'll find that to be true when you plug these values in. Here it won't give you a true statement. And that's because that happens sometimes when you square out a radical, when you square in on both sides to get rid of a radical. So your answers should be pi over 4 and 7 pi over 4.